Okay, Assalamu alaikum everyone, and thank you for the opportunity to be here with you today. My We have a workshop on Windows investigation, which is a case we created for our training and our workshops. It's a two-sided training, so there is one side where we have the Windows part. The other part is the Linux part, which we won't be covering today, but you have access to all of the data set. If you want to download it, play with it, completely up to you. If you do want to follow up and see how we will be solving this case, then part of that will be, hopefully we'll be able to cover as much as we can today. But the other part, you can follow us on our webinars where we do go over the investigation itself. So it's about digital forensics. It's about an investigation. It's a two-side case. We have, again, a Windows system and we have a Linux system. The Windows part is for the victim, and the Linux part is for the threat actor. Our webinars, by the way, just to kind of give you an idea of them, all of our webinars happen on the first Wednesday every month. So first Wednesday every month, we have a webinar for 1 hour, excuse me, and it's usually at 12 p.m. Eastern time. So you can probably, by the way, if you register on our academy, then you will get a notification for that. But if you don't, then probably just follow us on social media, whatever, and or maybe just put it on your calendars. We do it again every Wednesday, every first Wednesday, every month. It's for a one hour, and it's usually at 12 p.m. I think that's around probably 7 or 10 a.m. at your location, 10 p.m. at your location. So hopefully it will be convenient for you to join us. If you can join us, we do our best to record them, so then later on you can follow along with what we are doing. So thank you all for joining us today. Thank you for Hamid Iqbal for inviting us. It's a pleasure to be here with you today. My name is Ali Hadi. I'm the co-founder of Cyber5W. I'm also an associate professor at Champlain College, and I also am the research director and the director of investigations at the Lay Center, which is our research center where we provide different research and services to the local state of Vermont here in the US. And my interests are DFIR, definitely, and adversary simulation.
Assalamu alaikum and hello everyone. My name is Mariam Khadir. I'm also a contributor at Cyber5W. My current work, I work as an assistant professor at Champlain College, teaching digital forensics. I'm also a research lead at the Leahy Center for Digital Forensic and Cybersecurity, and my interests are DFIR and data science. This is my Twitter handle if anyone is interested to follow. Thank you so much, everyone, for being here today. So we try to always have some quotes for us. This one of our favorite is education never ends. It's a series of lessons where the gets for the last. We always believe that we should always be learning, and the learning will never stop. So what we are going to cover is Windows artifact investigation, and for that we are going to go over specific steps. First of all, we are going to cover evidence verification, which is a very important step when you are working in forensic investigation. Then we are going to talk about mounting, what does it mean? Then we will talk about extraction, how we do extraction, how we do processing, what are the tools that are used for both of extraction and processing. We will talk about how we can improve the initial access, which means how the threat actor was able to access the victim system. We will talk about the persistence mechanism and other activities. So how was the threat actor able to log in back again to the victim system? We will do our best to cover the logs, the RDB, and the services, how we can analyze this and also get artifact from these data. And finally, we'll talk about TeamViewer and Ghost Task, which was like one of the main, let's say, tasks that are created by the threat actor in the victim system. So a general overview for the scenario that the victim said that the victim was fall for a phishing attack, and the attacker was able to control the victim system, which allowed the attacker to execute command and capture a screenshot of the victim, log keystroke, and extract SAM database content. However, what we were like, this is the scenario. What we were told is that the victim, after receiving an email about installing WinRAR, the victim started to see like weird stuff happening in the system and the machine, and we want to investigate from that point. Now,
Probably just sorry, Mariam, to interrupt you. One note, everyone, is this meeting is recorded, so you don't need to record it. By the way, we are going to be recording it, and the recorded will be shared with you. So you don't need to worry about that. The slide notes will also be sent over to Hamid, and the video recording will be sent over to him as well. So you don't need to worry about that. We will be sharing all of that with you. Okay, so don't worry about that. Yes, sorry, Mariam.
okay, it's okay. So these are just like a few questions we put to help you go over the or to walk through the case. So during the investigation, and by the way, we have an image of both of the victim system and the threat actor system, because this is an internal investigation. Both of the attacker and the suspect work in the same company. So we have an image of both of them. We have an image of Windows system, which is the victim system, and we have an image of a Kali machine, which is the threat actor system. So what we need to do is that we need to answer these questions to help us work through the case. What did the threat act? How did the threat actor gain access to the victim system? What was the main reason? What are persistence mechanism that has been used? What did the threat actor do in the system? How did the threat actor knew the victim's TeamViewer ID and password? And did the threat actor use TeamViewer credential to access the victim system? So to answer these questions, we are going to go step by step. And what we're going to do is that we're talking about the slides, and we're also gonna go and work directly in the lab. Is my voice clear? I'll do my best to talk slowly. Maybe that will make it more clear. Thank you so much. Okay. So the first thing that we are going to do is I want you all to make sure that you have an access to the Windows machine, and there is a VHD tool that we shared with you. So if we can go here, there is a VHD file.
It's not on this system, but they have
Okay.
because they need it for the
Yes,
tools.
okay.
But we didn't download it on ours.
So the only thing you need to do with that VHD, just double click on it, and you will be able to see all the tools.
Mm-hmm.
Okay. Got the slides. So the first task that we are going to do is, and I know that everyone now has also the E01 image of the Windows. We don't need the Kali today, so just make sure you have the Windows image. And the first step that we are going to do is the verification. The verification means that the E01 file that I have received is intact. Nothing has been changed in that file. And that's why we do evidence verification. We want to make sure that before we start the investigation, that the evidence file we have is correct and have no issues. Usually, when you receive an image of a system, it's going to be either an E01 or a DD file. I know that we have an E01, but it might be an E01 or DD file. What is the difference between them? A DD image is a whole image of the disk drive, the whole, this like a bit-by-bit copy of the disk. However, the thing with DD is that if, for example, the disk was 1 terabyte or was large, the DD will be the same size as the disk. So it's going to be a large file size. E01 have a nice feature, or better feature than DD, is that you can compress it, for example, and you can add metadata, etc. So usually you will see an E01, not DD. Now, another difference.
Can you, Professor, explain what is this being used for? The E01, just as for tell them it's used for evidence.
Yeah, so the E01 is an image of the disk.
Yeah.
Yes. So the special thing about E01, it's not just a raw image of the disk, it's a raw image of the disk with metadata of it. The metadata will contain things similar to the hash value of the drive. The hash value will help us to make sure that the image drive has not been changed and everything is okay. It might contain other information like the acquisition date, the investigator name, and other metadata regarding the E01. Now, why am I talking about this? One important thing when we talk about verification is that if you have an E01, you need to use a forensic tool to verify the image. You can't use just a regular file like an HashMyFiles. So for example, HashMyFiles is used to create hash of the image, but we can't use it because, as you see here, an E01 is image of the drive and metadata. So I need a forensic tool that understands how to extract this image drive or drive image and then create the hash of it. The tool to do this is FTK Imager. This is what we have chosen. So if you all have FTK Imager in your VHD, we already have installed it here. It's easy to use the FTK Imager. The only thing you need to do is go to File, and we can select Add Evidence Item. So this is my evidence that I'm going to add, which is the E01. We have 4 options. This is for the drives that already in your system, but we already have an image file, the E01. So what we can do now next, and then please enter the source path. We are going to go to find where is our E01. So here is our evidence file, image file. We can just add it, and then you can see the image here. Of course, FTK can be used to explore and the content of the image, but the only thing we are going to use FTK now is to verify the image. So if you right-click and select Verify Drive Image, it will start to verify the content. When this finishes, this is what you should see. You should see an image like this or a window like this. The window says that the MD5 hash has been computed and compared with the hash inside the E01, and there is a match. And also another hash has been computed and there is a match. This means that the evidence is okay, and we can start our investigation about this E01. So this is the verification. We just make sure that our image is okay, and we can continue to the next step.
Okay. So mounting the image, now that we have a copy of, or the evidence that we want to work with, now in order to start doing our investigation or applying whatever tools we want to do on the evidence, we need to mount the image. So one of the things, and mounting, by the way, is a form. You can think of it as a form of connecting an external resource to your system. So that way, if I have let's say an external drive and I want to access the files within that drive, I need to mount it, and that mounting will allow me to now connect to that drive and look at the content. So the same way happens, especially again, if you have an external drive or like a thumb drive, a USB, when you plug it in, what's happening behind the scene is it's getting mounted to your system, which is kind of like getting connected to your system, and that way you are now able to access the content. The same thing we need to do when we are talking about attaching or mounting our forensic evidence, so that way we can start applying our tools, etc. So that's part one. Now, mounting is very important, by the way, because again, you needed to start your investigation. And one of the best tools out there is Arsenal Image Mounter. Now, Mariam was already showing you the FTK Imager. We can use FTK Imager to do mounting, but Arsenal Image Mounter is probably the best tool out there that can do mounting and provide you with different capabilities that FTK cannot do or any other tool can do out there. And we won't be showing all of that because that's they have a complete course for it. But probably during our webinars and sessions, we do mention different techniques and different features in Arsenal Image Mounter, and we go over them. But for today, we'll just use the basics, which is what you need. And it also is part of the free version. So Arsenal Image Mounter have a free version, and they also have like a professional version, which adds a lot of other, I would say, capabilities. So I would say, please write any questions you have. We will come back to them at the end and try to answer as much as we can. Okay. So if you have any questions, please do ask. We love questions. Yeah, we'll leave them till the end of the session. So just so we can cover as much as we can from the investigation, and then we'll get to the questions. So again, this is Arsenal Image Mounter. Once you download it and start the tool, it will install a driver allowing you to now use it to mount evidence on the system. Now, usually there is I would say, the default option, which is disk devices read-only. So that way you are not modifying the evidence, which is very important. Okay. But sometimes we need to do some modifications, and those modifications, by the way, will not jeopardize the evidence that we are working with. So these are let's say, think of it like this. You want to access a file or a folder that your user does not have access to. We need to change those permissions in order to be able to access the file or that folder. So when we mount the evidence as write temporary, what happens is Arsenal Image Mounter will create a temporary file to store all of those modifications in there. Once we, let's say, unmount the evidence, those modifications are no longer applied to the evidence. So nothing happened to the evidence. The evidence did not change. It was intact. The only changes were to like a temporary file in order to emulate the idea of changing some settings or whatever. So I'm going to use the disk write. I usually prefer this way just so I don't get into problems. And I also use the delete differencing. And that's because unless I want to kind of, let's say, do part one of my task today, and then I want to go home, come back tomorrow and continue, then I might not delete this. So, but in our case, today I'm just going to leave those. And now it's going to ask me, where do you want to store the diff file, which is the difference file? Okay, so I'm going to store it on my desktop. So we can see now that we have 3 volumes, by the way, that have been mounted onto the system. So if I go to, like, quickly just to show you, and if we go to disk management, we can see that we have the recovery, we have this EFI volume, and then we have the NTFS volume, which is probably where our system that we want to investigate is located. So we can see this is, by the way, the volume or the system that we will be running all of our investigations against. Okay, so just to kind of show you that. Now you can see that these are the volumes. The GUID for these volumes is telling you the partition layout or the drive layout, which is GPT. So in this case, it's using like a GUID partition table. It's telling you the disk size. So this is a 32 gigabyte, disk size. Even though the image, by the way, was much less than that, the image, I'm sure some of you have already downloaded it by now. The image size was not 32 gigabytes, it was much less, but this was the size of the disk itself. And yeah, that's the so Arsenal Image Mounter can do that, and then also FTK Imager can do that. Let's see if the verification ended, so that way we can show that before we move on to the next part. So I think it's about to finish the verification. Yeah, let's continue then probably. So
Okay, thank you. So after we were able to mount the evidence file or the evidence image, we want to start evidence extraction and see what data can we extract. There are different ways that we can do to extract the image, the artifact, but what I want to show you first, I want to show you how we can do this manually. So in Windows, there are a lot of things that can help us to find out what happened in the system. One of these things is the prefetch files. The prefetch is a feature in Windows in which Windows keep a track of, if, for example, I want to execute Notepad like this, I want to run Notepad, Windows will go and search for all the files and directories and the libraries that Notepad require, and will record them in the prefetch file. This will make running Notepad faster for next time. So this is just a feature in Windows to make user experience better. However, for us, for a forensic investigation, if I find a prefetch file for Notepad, then I can say for sure, yes, the user has executed Notepad on the system. So we can use a prefetch as a proof that an application was executed in a specific system. Okay, so prefetch is a good source of artifact. Where can we find the prefetch? If we open any file explorer, the prefetch can be found in the C drive. So in our evidence is in the F drive. So if I go to the F drive, the prefetch will be stored in the C Windows, because this is the C. Under Windows, there is a folder called the prefetch. Here, all the prefetch files. So if you look at this, I know now just like files, these are the prefetch for all the application that has been executed in the victim system. So we can, for example, see CMD, we can see, for example, Firefox, we can see, for example, Microsoft Photos. This is proof that all of these applications has been executed in the victim system. So we can use this as our start point to know what are the executables that has been executed in the system. So what we can do also is that, let's go to one of them, choose one of them. For example, we have the Notepad++. This is the prefetch file for Notepad. So the first thing we were able to prove that Notepad++ was executed in the system. I know that Notepad is not suspicious, but I just want to explain the idea of a prefetch. What we can do is that we can analyze this prefetch file. How we can analyze this prefetch file? There is a set of tools for Eric Zimmerman. These tools can be used to analyze Windows artifact. So, and you will find this in your VHD tools. So here under Eric Zimmerman tools, if you go, you will find a tool called BECMD, which is the prefetch file analyzer, and it's a command line. So what I'm going to do, I'll open a CMD, and I'll open it, I'll run it as an admin. Now I want to change my path because currently I'm in the C users, IE user. I want to go to this location where is my prefetch file is. So what I can do is type E. This will change my current path to the E. I'm not sure if you can see this. I hope that the font is good. I'll make it a little bit larger. I hope this is better. So I want to go to Zimmerman tools and net6 here. Now, if we type BECMD.exe and just without any options, click enter, this will show you all the options that you can use with BECMD. So all of the tools that Eric Zimmerman has developed have this like help menu. So for example, if you type BECMD -F and then the file name, this will analyze this calculate file. If we use -D, for example, this will analyze a whole folder for like different prefetch files. So you can analyze one file or different files, multiple files at the same time. And you can see here we have the different option, -F to analyze the file, -D for a whole directory. For example, -CSV and CSVF if I want to store the result inside CSV file, which will make it easier for us later to understand the output. So what I'm going to do, I'm going to clear the screen for now. Now we know that the victim said all the problems or the weird stuff started after running WinRAR. However, if we look here and try to search for any WinRAR file, we don't find any WinRAR prefetch file. Now the question, does that mean the WinRAR wasn't executed in the system or the prefetch file was deleted? This what we can do now is that we can use different artifacts to understand this. But let me show you how we can analyze the Notepad++. What we can do is that we can write BECMD, then -F. I want to analyze one file, and my file is on the F drive, Windows prefetch, and its name is Notepad++. This is the file that I want to analyze. Important thing for us is that I want to store the output in a specific location. What we can do is that I'll go to my desktop and try to create a new folder. So in my desktop, I'll create a folder. And this folder will be used as the output for my data. I'll call it prefetch output. This is monitor. So I'll store the output here. So it is in the C. IE user, this is my user. In the desktop, we have the prefetch output. So what will happen now is that BECMD will analyze this notepad.pf file, and the output will be stored in the prefetch output. We can also say or add this option -CSVF, which means that I want to name the output file to be prefetch output, let me put underscore, .csv. So my output file will be prefetch output.csv. When you click enter, you can see that the file has been now analyzed. You can check the CSV file, or you can look here at the data that we have. So the file has been analyzed is Notepad++. We can see information about creation, modification, and last access. These are for the prefetch file. So I know that this prefetch file has been created in this date. And this is nice thing. The time the prefetch file was created will indicate the first time the user executed the Notepad++. And the last access, this means this is the last time the user executed this file. So we can know that Notepad application was run the first time at this time, and the last time it was run at this time. We have the executable name. We have also the last runtime for it. We have other runtime. So Windows store the last 8 times this application was running in the system. Here's another important information about prefetch. You can see all the directories and the files referenced by Notepad. So you can see, for example, let me try to find something interesting. I think at the end we can see some interesting files. So far I have DLL. So we can see that this XML file has been opened. We have software.txt file has been opened. We have the change.log. So you can see all the files that have been opened by Notepad here. Now, I know that in our case, when we look at the prefetch, the WinRAR.prefetch was not there. However, if we keep looking and trying to find anything interesting for us, we can see that one important thing or like interesting file is sdelete.exe. If you know, sdelete is a file used for wiping data. So why this file was executed in the system? What we can do is that we can check what sdelete did in the system. So we are going to do the same thing we did, but we are going to do it for sdelete. So what I'm going to do again is BE-CMD, then -F for the F drive, Windows, and prefetch. And here we will add the sdelete to the prefetch file. We just want to see what are the files that have been opened by sdelete and in the victim system. Now for the output, we are going to use the same output, which is C users, i.e. user. It is on the desktop, and we are going to store in the prefetch output, and -CSV is this is sdelete.csv. Now here for sdelete, we can see the same thing. This is the time when sdelete was run in the system for the first time. We can see the times when this application has been executed in the system. We can see the directories and the files that have been opened or used by sdelete. We can see, for example, this one, t.txe. So what is this file? And it is stored in the TIM. So this is one of the things that will help us to find like artifact or suspicious entries about what is this file, which is in the TIM. This might be something that we would go and see, like why the user did delete this one. It's not the user, it's mostly the threat actor. Why did the threat actor delete this file, t.exe? We can also look and see if there are any other interesting stuff here to see in the prefetch. So this is the information that the prefetch can show us. It can show us the first time the executable run in the system. It can show us the last time it has been executed in the system. It can show us also how many times the application was executed in the system. So all of this information can be helpful for us in our investigation. I know manually this might take a long time. So what we can do is that we can use a tool called Cape, which can, Cape will go and search for all files of interest like this, and will put them for you in a specific location. So instead of going and looking for all the prefetch file, the link file, registry files, we can use Cape to do that. So what I'm going to do, if we go back to our tools, our tools were in, I think it's here in the tools, and we have Cape. So I already used a tool from Eric Zimmerman, and this Cape has most of the tool in one application. So if you use Cape gonna go and extract all the artifact for you. So there are two versions of Cape. There is a command line version and there is a GUI version. It's gonna be easier for the first time to use the GUI version. So if I do double click, this will run gcap for us. It's taken a minute here to execute. So that's the idea. If since the prefetch file was removed, we can find a lot of other artifact to find it. the threat actor will try to remove as much as they can from the system, but you will always be able to find something, hopefully to find or to prove something happened. Now in GKIP, what we are going to do is we are going to use something called target options. Now target options is the victim file image is what we want to investigate. So first of all, what is the target source that you are analyzing? The target source for us is the F, which contain the victim image. And we want to determine a target destination. So in my desktop again, I'm going to add a folder, and I'll call this folder CABE output. So here, this is my target destination. In my desktop, I have the CABE output. Now, as you can see, there are a lot of options here. One of these options is I want to show you the prefetch, because we already talked about it. So if you double click here, you can see that CABE knows that prefetch files are stored in the Windows prefetch, in the drive Windows prefetch. And it's gonna go and extract all the files for you and put them in one folder. So instead of going manually copying all the files, CABE will do that automatically for us. And the same for other artifacts. So for example, for the J file, the log file, the MFT, if you look also for, let's see the other ones, for the link files, the jump list, instead of going and manually extract all of these artifacts, CABE will do it automatically. One of the nice features in CABE is something called compound file. As you can see here, this one is compound, and one of them is sans triage. What you can do, if you double click, you will see that it goes and look for most of the artifact for you. So we have the link file here, we have the recycle bin artifact, the registry artifact, the schedule task, execution. All of these artifacts will be executed. So instead of going manually, we can just select this, select the sans triage. We have the target source, the destination, and you can also determine the output for the file that you want, so that when all these artifacts are extracted, it can be stored in VHDX, for example, or VHD, and the name of it, K output, I'll call it .vhd. This is what will happen. It's going to be compressed. We also might want to process volume shadow copies. Volume shadow copies are like restore point, can also contain important information for us. So I'll do this. I'll click execute. This will start extracting the data. The warning message here says that you selected the flush option. It means that the output folder, which is K output, will be overwritten. So, okay, it's already an empty folder for us. And it will start just extracting the data for us. So all of these prefetch files, link file, etc., all of them will be running. Let me just make sure. I want to make sure it has been, at least FTK is running. Okay, so we need to make sure that we don't have FTK running. So
we can do two things, by the way, but yeah, we better probably to close it.
Yes.
So close this first.
I'll close this. I'll make sure to close FTK Imager. And just a minute. We wanted to make sure also that we have the verification. Okay, before closing FTK, we already have the verification done, and we have the match. That's great. We can now then close FTK Imager. Okay, what we can do instead, we can just say ignore FTK warning, and we can start executing our extraction. It shouldn't take a long time, but it will extract everything and will store the VHD output here in the CABE output. So we already now started extracting the artifact. We already talked about the prefetch. Again, prefetch is just a Windows feature, but for us, it can help us to find and prove that an application has been executed in the system. We haven't found the WinRAR, but we saw that sdelete, for example, was used. You can see like there are a lot of other applications has been executed in the system. So even if we didn't find anything in the prefetch, that doesn't mean it wasn't executed in the system. We can go and check other artifact in the system to prove that WinRAR was executed or not, and what happened in the system. Okay, Professor Ali?
Okay, so let's continue our investigation. And this time we're going to look at SRAM. So SRAM is the System Resource Usage Monitor, which is another feature on your Windows system. So one thing I know, one of like the questions was, what if like the threat actor went and deleted all of the evidence? Unfortunately, by the way, I would tell you, for a threat actor, it's very complicated to cover everything, all of their tracks, because Windows is really tracking a lot of the user activity on the system. So while you go delete one, there is others which are going to be there that you can use. So as an investigator, your goal is not to focus on one single artifact, but actually understand that with what activity that a user does, what can I find in front of that? So if, let's say, I go ahead and delete a file, what can I find to prove the file was deleted? If I go and start an application, like Professor Mariam was saying, one way of checking is to check the prefetch files, and there are others. So even if you go, and like this case, we kind of like made it on purpose with that kind of idea in mind, like anti-forensics has been applied on the case, we can still do investigations. We can still do investigation. We can still prove something has happened and what has happened on that system. So let's go ahead and now look at SRAM. But before I do that, I just want to kind of explain where is SRAM kind of coming from. So when you look at, for example, your application history, you can see each one of these applications, and it's, as you can see, it's also recording. It's recording like the CPU time, network usage time, how many bytes have been sent, how many bytes have been received. All of those details, by the way, are being recorded, okay, on your system. So what that means is, if an application has been used and that application no longer exists on the system, which in our case, like Professor Mariam was checking the prefetch files, we didn't find a prefetch file for WinRAR, right? We didn't find one.
Yes.
So does that mean WinRAR did not start on the system? And especially, by the way, that the victim was already telling us that after they used WinRAR, there is no longer any that's after they used WinRAR, that's when things started to happen and started to go weird things happen on the system. So if the user was telling you WinRAR was used, we can't find WinRAR in there, then that's really suspicious, and we need to find out what happened. So, and that's what we are going to do here. So if we go ahead excuse me, if we go ahead now and so look at the CAPE output, so we can see the output. I think CAPE is done with the extraction part. So CAPE is done with the extraction part. The output is now saved in this location, and the reason why they are in a they are going to be because they are in a VHD. So if we extract this, we can see now we have a VHD, by the way, with all of the evidence inside that. This is probably similar to the VHD you have for the tools. So if you want to access the content, all you need to do is double click on it. Now we have access to the content. Now, as you can see here, F is the drive letter being used because, as you can see, the volume we are investigating is mounted under the drive letter F. So that's why we can see F in here. But then the whole file structure, by the way, is the same. The whole file structure, like we can see on the F, we can see the extended program files, program data, users, etc. Now you might say, wait, where did these come from? Like, where did these come from? So one thing, by the way, here, I'm just going to mention this quickly, is these are file system like metadata. So these are related to the file system itself, which is the NTFS file system. So if I go ahead and attach like the physical drive, or maybe let me do the logical quickly. So if I go ahead and do this, and now look at the content of the volume, I can see these files, which these are the files in there, MFT, etc. This is for another session probably, or again, if you check our webinars, you'll find a lot of details about that. But these are all files that make the NTFS file system. When you go to your file system, so if you go to the, let's say, Windows directory, you won't be able to see them in there, even though they do exist, by the way. So these are files, these are in your on your volume, but they are system files and they are hidden from the regular user. So you won't be able to see them unless you are using a forensic toolkit like FTK or whatever. Okay, but these are all, again, NTFS files in there. So if we continue, the idea here was to talk about SRAM. So what we can do now, if we go to the F, we can see Windows. And then if we go to System32, and then in the SRU directory, we can see the SRAM database. So this is, by the way, where all of the evidence is being stored. So all of the SRAM data is being stored in this file. Now what we can do is use a tool. So let me just double check. So there is a tool called SRAM ECMD. And as you can see here, all of, I would say, the good thing here is all of Eric's tools, by the way, come with this like help menu. So you can easily know what do I need to do in order to kind of, let's say, run a tool, because as you can see here, all of the help is in front of you. So in our case, what we want to do is -F to select a single file, which is the SRAMDB, and our SRAMDB is located. We can directly do that, or we can pull this, because we've pulled that. What happened here? Okay, so if we do this, and then the DB file, yep, and then what we need to do is, where do we want to, we also need the software hive. So it's good to also attach the software hive. So -R to process the software hive with it. So let's go ahead, and the software hive, by the way, is also C Windows System32 config, and then we have the software hive over here. So -R, and then we have the software. And then where do we want to store the results? So let's say CSV, users, iUser, desktop. I'm going to create a directory called results. And inside it, I'm going to create a directory called SRAM. So that way we store all of our evidence in there. And then if I hit run, this is now going to go and process the SRAM database and store the results in that directory over there. So let's wait a little bit for this to continue, finish the processing. But if we go now to our desktop, and let's wait a little bit for this. If the database is dirty, okay, so we probably need to fix the database. So, and this is probably because, by the way, it has been kind of, I would say, ripped. The database is being ripped. So what we can do is we can fix it using this. So in our case, we will do that, and then we have our database over here. So if we do this, the file is accessed. Let me see. Oh, I know why. Because this is a VHD file and it's mounted as read-only. So let's copy it, no problem. So let's copy the file. We can do that. So copy the file to our users, IE user, and then desktop. And then let's create a directory called results, SRAM. I know why, because I don't have this directory. I did it on purpose, by the way. Now, if I copy the file, so one is done. So if I do the essential now, and C users, IE user, desktop, results. No, not this one. Results, yep. And then, okay, so now, yep, we should be able to operation finish successfully. Now we can go back, by the way, and do the use the SRAM. So let's go back. And in this case, now we have the database, which is over here. And it's called SRAM, or sorry, srudb.dat. And now I can process it. Yep, so now we are good. We were able to process the file. And again, by the way, just in case you are asking why did it fail the first time it failed because we were processing the file directly from the I drive, which has the evidence in there. And this is a read-only file system currently, so we can't modify the content in there because it's mounted as read-only. So anyway, we just need to copy it and then fix it, and that's it. Now that we have, the evidence, we can use a tool like Timeline Explorer, and you can use Timeline Explorer or you can use like Microsoft Excel. It's really up to you, but this is a really good tool for looking into CSV files, which is a comma separated file. So let's go and do open, desktop, results, SRAM. Now in here we have a lot of output, as you can see. What we are interested in is the application resource usage. So we are interested in this, and we are also in the network usage. So we can pull actually all of them just to see which one we will have some data in there. Let me maximize this a little bit. So if we go to the app resource usage, you can see here we have all of the applications, by the way. Okay, the timestamp, we have all of the applications that have been used and by which user. So we can even categorize them or filter them by user. So the way to do that is right-click on this and say group by user. Now we can look at each user like separately. So let's say you want to focus on user 1 because that's probably the user you want to investigate. Then now you can just focus on this user and see what were the tools that have been used or executables that have been used by this user. Now, one thing which the reason why we came here in the first place is we wanted to check the WinRAR application. So let's see if WinRAR has been used. And as you can see here, yes, WinRAR, as you can see when we did the find, it kind of filtered out everything. So down here, you can see the total lines. We have 2971 entries, but now we are only seeing one single entry in there, and it's telling you when was this executable actually started. So this is great for us, by the way, so we can see here how many bytes were read, how many bytes were written, all of that. And this, by the way, proves that this executable was used on the system. Why didn't we find it in the prefetch file? We still don't know yet, but there might be a reason that, or our suspicion now probably is because this executable has been deleted or removed from the volume. So again, even if prefetch, the user went and deleted it, we still can look at other locations and then delete them. Now these files, by the way, someone might say, oh, I'll go and just delete the entry from this database. Now, it's easy said than done, by the way. These are binary files, and these binary files are all controlled by the Windows system. So you'll need high level and probably like privilege escalation in order to, in the first place, access these files, and then in the second place, modify them without corrupting or damaging these files, and then the system might get corrupted itself. But even if that happens, by the way, there are still ways to pull these files and investigate them. Let's look at also the network usage. Sorry, not this one. The network usage over here. And again, we can filter based on the user. So if you want to do that, you can do that. Just again, right-click and say group by. And now I can focus on the user. So if I look at the user here, I can see these are all of the executables that have been used by this user. Now, did WinRAR start? I know it's over here, but again, you can do a quick filter. So WinRAR, and if we do that WinRAR, we can see that the exe has been used. It's also showing me that this WinRAR, not only was it used on the system, it was also sending back and forth some it was sending back and forth, some data. So there was some data being sent and some data being received. Okay, so we now have proof that we know the victim told us that WinRAR was used. We didn't find it in the prefetch file, but now we did find it in the SRAM database. It has been used, and it's also sending some data over the network. So if we continue our investigation, and by the way, all of the commands that we are using, you can find them in the slides, but also at the same time, there will be the recording. So just a reminder that you can then follow these later. Now, another location which we can look at to find evidence of execution. So if a user, let's say, started an application, and then that application, we want to prove that it was used on the system, we can also look at user assist. User assist is a set of key entries, by the way, where it will store the usages of executables and apps on the system. So when a user goes and like double clicks on an exe or a shortcut, what this does, it will also go ahead and record an entry in there that says this user has been, this program has been used by this user. Now, this is going to be stored within a registry file called ntuser.dat. So it's per user. So every user has an ntuser.dat file, which it will store all of their preferences. So if we have, this is the system we are investigating. We have this user, and we have this user, and this is the public, which is the public user, and then this is the default, which is kind of like templates which Windows uses to create these registry files. Now, this is the ntuser.dat file. Now, you might say, what is the Windows registry? Think of Windows registry as like a database or as a file system, by the way, and I usually refer to it as a file system just based on the like the structure on how it works and how things are structured within this file. So it's kind of like a special file system. But if in general, usually people refer to it as a database, and this database will store all of the users' preferences. Now, this database, by the way, or this file gets created the first time the user logs onto the system. So when let's say the admin creates an account, and then the user goes and logs onto the system using that account, this file gets populated and created, and then all of the different preferences that the user does, let's say saving like the background image, what type of screensaver, what type of settings, applications usage, etc. All of those are usually going to be stored within this file. Okay, so it has a lot of information that we can use in our investigation. Now, what we can do is we can use a tool called, also from Eric Zimmerman, And it's really, by the way, up to you whether you use Eric Zimmerman tools or Autopsy. Autopsy is also a great free tool. Usually we prefer to use Eric's tools because that way we can focus on one single artifact at a time instead of like Autopsy. It will go process all of these evidence and then pull them all together for you. So it's good to start probably here, and even maybe later if you prefer to just use these tools. It's really going to be up to you. Most of the investigations I do personally, I use Eric Zimmerman tools, even though we have a lot of different commercial suites like Axiom, and we definitely have Autopsy and others like X-Ways, etc. Still, my preference will be these set of tools, and they are all free, so everyone can use them. So if we go to Eric Zimmerman tools, Registry Explorer, excuse me, and then open it. So open Registry Explorer. Please feel free to, by the way, ask questions. We will get back to your questions and try to address them at the end of today's session. So we have the Registry Explorer. We can drag the NTuser.dat. And now a good thing, by the way, about the Registry Explorer, even if you don't know where should I look for things, like, for example, you don't know about all of the details or all of the things that you need to look and check. Once you load the Hive, or this file, which is usually also referred to as a Hive, the Windows registry files are referred to as Hives. Okay, once you load it, you can go to bookmarks, and then in bookmarks you can see there are a lot of, by the way, bookmarks in there, and each one of them is going to take you to a location where you can find evidence of something, or you can find different details. So for example, if we go to run, we can see in here what are the programs that are supposed to be used or executed at runtime. So when the system powers up, so when you first start your system, what is going to be started with your running system? We can, if we go there, so this path, by the way, we can see that we have OneDrive and Microsoft Edge Update. Now, one thing to keep in mind is this is per user. So what that means is if I wanted to investigate, let's say, the other user, then I would need to go to the other user and load the NTuser.dat as well, because that's a different file. So now if I go here, this user, and if I go to bookmarks again, and as you can see, by the way, I'm not sure if you noticed or not, but in the first user, let me just in the first user, we have 29 entries. In the second user, we only have 24. Now, the thing is, the tool, these entries get populated, by the way, based on the evidence or based on the artifact which is found within these hives. Excuse me. So if there is some data in there and there is a bookmark associated with it, it will be populated. But if there is some data in there, if there is no data, sorry, in there, there is a bookmark, the bookmark will not get populated. So once you see there's an entry in here, you know there is something in there, and you can kind of go and check it out. Now, not everything might be relative to your investigation. You might not be like interested in printer ports. You might not be interested in that, or it's not relevant to your investigation. But in general, what I'm saying here is these entries do get populated based on the data which is found within those hives. So if we go here again and probably like check, as you can see, run, if we go there, we can see this one has different entries in there. We can see this one has a OneDrive setup, and this is probably like the first time to run it. And then we also see the OneDrive and the Microsoft Edge update. So I'm just kind of trying to show you that we don't necessarily have the same data, because I might be using my system for one thing, you might be using it for something completely different. So it's not going to be the same. But anyway, let's go back to user one, the the bookmarks. And then if we go down to the end, you can see user assist, and then these are your recently accessed items. So if I click there, now one thing I would say, if you're using these entries, by the way, if you're using an older version of Registry Explorer, or if you go to the entries of these entries in the Windows registry. So for example, you can see this is the path, by the way. So let me copy the path, and I just want to show you one thing quickly. So if I go to regedit, because by the way, this is where all of this is being pulled from. And if I go to current user, and it's telling me it's under software. So if I go to software and then Microsoft, so if I go to Microsoft and then Windows, so if I go down all the way down to Windows, and then current version, just following the path that I'm seeing over here, and then Explorer, also follow the path, and then finally user assist. So if I go to user assist over here, and then if I go to these entries, by the way, and look at them, this is what you're going to see. These are, by the way, using Microsoft stores these entries in an ROT or ROT13 format, rotation 13. So this is kind of encoding them in ROT13, and it's storing them in there. If we come here, we can see that the tool automatically was parsing this and applying ROT13 for you and giving you the answers automatically. If you go to the values, by the way, so if I expand, go to the same location, count, okay, and you look at the values in here, we can see them in the original format. So you can see this is how they are originally stored on your system. But you can see there's a plugin in here which is kind of pulling the evidence for you and applying the encoding format and applying the encoding here. So it's decoding it for you and it's giving you these answers. So as you can see in here, we were interested in WinRAR. So again, let's just check whether WinRAR was used in here. Definitely in your case, by the way, probably do more checks and like explore more. But for the sake of the time of this workshop, we won't be exploring every single piece in here. But usually in a normal investigation, you will need to spend more time on this because you don't know the answers. You are looking for the answers. In our case, we know the answers because we did the investigations previously, and now we are showcasing like how to approach this. So if we look at this, we can see the run counter. So the run counter, it says 1. So that means it has been used at least once, okay, because it has been used once. And then this is when it was last executed on the system. So as we saw here by looking at the prefetch files, we didn't find anything. It wasn't, by the way, a lack of what Professor Merriam was doing. It was because there wasn't a prefetch file associated with WinRAR. Why is that the case? I'll leave that to you, or probably we'll cover that either in the end of today's session, if there will be time, or in a future webinar. But that's for you to investigate. So, but can we still prove that the executable was being used on the system? The answer is yes. We found it in SRUM. We found it in user assist. So we can still say that this executable was used on this system. So if we continue. Now, another thing that which is also important and it's good to check is mark of the web. So mark of the web, or MOTW, MOTW of mark of the web, it's kind of like a security feature in Microsoft Windows that it will tag or flag or whatever you want to call it, any file that gets downloaded from the internet. And what it does, it stores within that file as an alternative data stream. So NTFS has a feature or a capability of using what is called an ADS, alternate data stream. So with that, what it does, you can store and think of it as another container to store data within the same file or associated with the same file. Okay, now in that container, what is stored in there is the location where this file has been downloaded from. So when you download a file, it will store in there where has this file been downloaded from. So let's go ahead and look at this, by the way. So if we go to our evidence, so if we go to users, and if we go to user 1, and if we go to downloads, we can see, by the way, this is where WinRAR, and I need to stop my Windows Defender. And this is probably, by the way, especially in cases where you suspect that there is a malware or any kind of malicious software being used, it's good to use like Windows Defender or any kind of, let's say, antivirus to scan your volume or scan the evidence system, okay, to check if you have any malware in there. As you can see, the Windows Defender automatically deleted them. So let me just go back, not this, sorry. Windows Defender. Let me just go back in my case. Sorry, again. Yeah, this one. Threat history. And this is the one I want to restore. So let's see, was it restored? Not this one. Yep, downloads. Yeah, it is being restored. Okay. So if we go ahead and do CMD, let me try to increase the font size for you. So probably this is better. Yep. So if we do dir, by the way, with the question mark, we can see that if we want to look at like ADS or files that have an alternate data stream, we can use a /r option in there. So if I do dir /r, I can see that this file, sysinternals, has an ADS in there, which is a hidden file, by the way. As you can see, if I just show you, I can't see that in here. And even if I go to view, and even if I say, let me go and do that. So as you can see, show hidden files, I removed all of, I've already unchecked all of this. So there shouldn't be any hidden file in here, but I still can't see this. And the reason why is this is kind of like a hidden system file, okay? And it's part of the NTFS file system, or it's only available on, I would say, on NTFS file systems. So we can see that this sysinternals.zip file has one, as you can see here. And then the WinRAR also has one. So what we can do is we can go ahead and access this file. So if I do notepad.exe, or even without the .exe, and then let me do this. Did I start it incorrectly? Yeah, I can see now. So when I open the file, let me just show you one more time what I did, just if I did it fast. Notepad WinRAR, that's the name of the exe. And then I need the name of the ADS, which is zone.identifier. So it is stored in the zone.identifier. And then if I open it, okay, I can see that it's telling me which zone it belongs to and the ID of the zone. I can see the referral URL. So I can see it has been referred to from this location. So the suspect, or the victim went to this URL, and then this URL told them to download the exe. So this is the full path to that exe. So this is where the exe has been downloaded from. Now, whether this is suspicious or not, that's a different story. But if we can kind of like, let's say, just an example, probably, if we go there, if we go to WinRAR and let's say download, if you look at the URL, by the way, if you look at the URL, maybe let me copy it, and maybe let me open another notepad file, and let me just store it here. As you can see, this is the real URL for the download, by the way. But what are we seeing here? We are seeing that first is HTTP, so it's not even HTTPS. And normally nowadays, all of websites are using HTTPS. And we can see that this is the path where it's being downloaded from, while over here, this is the path where we can see on the original website. So there is a suspicion here that probably we are not looking at the true WinRAR website. We don't have proof to that yet. By the way, we have no proof to that, but just something to keep in mind when you do your investigation. Let me minimize this and then continue. So again, this is going to be useful to find where was this executable or file. By the way, this is not for just for exes. Whenever you download like a document, if let's say I send you an email and that email contains a file to download, then when you download that, it's also going to be is going to be over there. Okay. Okay, so probably we'll take a break now. So this way we don't start a new part of the workshop, and then so we'll take a 15 minutes break. I'm gonna go grab more coffee because I'm a coffee person. You go stand up, stretch your legs, do whatever you want, grab something to eat or drink, and then we'll come back and continue in 15 minutes. So because again, we just don't want to start a new topic and then interrupt that. So we'll stop at this. We'll stop here, take a 15 minutes break, and then come back. So let's come back at. We'll come back at, let's say it's gonna be 32 or 33. So 10:33. We'll come back at 10:33. Okay. So I'm gonna mute my mic, and still, if you have questions, put them in there. But again, we'll come back in 15 minutes to continue. And yeah, go grab something to do, drink, eat, whatever, and we'll be back. Thank you. Okay.
We will leave 15 to 20 minutes at the end to answer all the questions. So excuse us for now, we're not answering them. Okay, now after everything we have found so far, we want to look if there are any persistence mechanism that was in that we can find in the system. There are different ways the threat actor can keep persistence or keep access to the victim system. Some examples are creating a user account, creating a service to be able to connect again, creating a schedule task, like the auto run. There are different ways that we can prove if there is a persistent mechanism technique or not. So what I want to start with, I want to start talking about the user accounts. So there are different ways to find it, but we already saw that we can use Registry Explorer to analyze the registry. So what I'm going to do, I'm going to extract another key in the registry, which is the SAM key. So just give me a minute. So our information were in the under F, where we can find the registry keys. They are in Windows, C Windows or F Windows in our case, system 32, and under a folder called config. So here we can find the different registry keys. I know the anti-user that was in different location, but that because it was for a specific user. These are system-wide keys, like we have information about all the users in the system. So the main ones that we are going to look at are the SAM, the software, and the system. The security also contain information like the user and computer SID. However, I'll take these three and add them to Registry Explorer. And as you can see, each one of them has the log file. The log file will be used to make sure that we don't have any problem with the registry key. So I'm going to select my SAM software and system files and add them to Registry Explorer. Okay, the first one is the SAM. The SAM contains information about all the users within the system. And if we go there, just to make sure that you select the SAM and go to bookmarks. In the bookmarks, you can find an option called users. This will give you information about all the users in the system. So we start with the user ID. This is the relative ID of the user. And we have also information like when the user was created in the system, the last time the user logged into the system, which is very important for us to find information, the last password reset, the last incorrect password, and we have the username. So we have the user administrator, which is a default user account in Windows. We have the guest, we have default account, WDAG utility account, user one, and default. So let me just expand a little on this in the user accounts. So is there any suspicious account here? If I go to my system and I can type this command, make user account get name. This will give me all the default all the users accounts in my system. So as you can see, every Windows machine will have administrator account. It will have a default account, the guest account, the WDAG utility account, and SSHD. Most of the time you will see this account. And this is my current user account. This is the main account in the system, IE user. So those are, let's say, not suspicious account. It's okay to see this account. But if I go back here to the case that we are solving, so we have administrator, okay, guest, default account, we have WDAG utility, user one, which is the username in the system, and we have default. This is suspicious because in default, like by default in Windows, if you know the user accounts in Windows, there is nothing called default. So this is number one. This is a new user account in the system. Another thing is that we can also tie it by the creation time. So this was created after the WinRAR was executed in the system. So these are two important things can show us that this is a suspicious account. And another thing is that, so we have the user account. This is a new user account, has been created by a threat actor. This is the time it was created, the last time it was logged into the system. We have the relative ID of that default account. And we also have the groups this user is part of. So we can see that this user is part of administrators group and part of the RDB users. So this user will be able also to create a remote desktop connection to the victim system. So this is one of the main, or one of the persistent mechanism technique the threat actor was able to create in the system. Okay, so this is one of the way that we can prove there is a persistent mechanism in the system or not. And it can be found in the SAM folder. If I go to the system also contains a lot of information that will be helpful for us. I'll go over them, like I'll find anything that can be helpful for us. For example, in the app compact cache, in the BAM also, we can find information about executed applications. So you can here come to the app compact cache. You can see here all the executed application in the system, or like at least the application in the systems. We can see the t.exe again. We can see the team viewer setup is here. We can see the sdelete. Let's search for the WinRAR, by the way. We can see, yeah, the WinRAR. At least we can prove that it was in the system. The WinRAR setup, it was in the system using the app combat cache. So this would just help us to say that, yeah, there is a lot of places where you can find information about executed application in the system. The BAM also can be used also to find information about executed application in the system. We can get other information here. We can get information about the RDB connection, but I'll keep this for later. Another thing is the services. So if we go to the services, that will show us all the services that are in the system and many information about them. So for each service, I have the service name, description, a display name for that service, how it is start. So these are disabled. these services will start at the boot time. The service will start manually. So usually if the threat actor will create a service in the system for persistence mechanism, it's gonna be start with at the boot time. The service type, what other information? We can see the image path from where it was executed and the privileges for that service. So usually we just do search and try to find if there is anything like suspicious here in the system. We can see that there is also the automatic start mode. So it's not manual. It will start when the user log into the system. We already did the investigation. We know that there is a suspicious service which is called network simulation. So as you can see, we have this service, and one of the things can help us is that it was created after or within the timeline of the incident. So this is one of the important thing when you do an investigation. We need to determine a timeline when the suspicious activities started, and this will help us to know all the changes that happened in the system. So this is when the service has been run in the system. It was running as SVC host. It's called NetSim. However, for more investigation, either we need to investigate the Kali system, which we might do in another webinar, or you can do a malware and an investigation to understand what does this service do. So we can see that there are 2 persistence mechanisms so far. A new user was created and a service has been executed in the system. Now, currently we are within the system key, and you can see that there are different artifacts that you can see. We can see the time zone information, you can see the USB, but for this case, there are no physical interaction between the user and between the victim and the threat actor, so we don't need to go to investigate this one. The last key is the software. The software also contains different artifacts, can help us in our investigation. We can go and look for the run and run once. So another way of creating persistence is to create an application and put this application within the run. This means that every time the user log into the system, it will be executed. I know we just saw that when Professor Ali was talking about the anti-user did that. So you saw run and run once. This is the same, but this is under the software key. And the difference between them is the run under anti-user did that is just associated with that user with anti-user did that. So if I am investigating anti-user did that of user 1, this application will be executed every time user 1 log into the system. However, if user 2 log into the system, it will not be executed. But if you find the executable under run under software key, this means that this application will be executed whether user 1 or user 2 logged into the system. So here you can see we have other executables, but we don't see anything suspicious here. So there is nothing suspicious in the run. In the run once, also the same thing. The difference between run and run once is that run once, it will be executed only once, but run, it will be executed every time the user log into the system. So when you look at here, we don't have any other artifact about anything that have been executed. We can see the tasks. The task is very important. So what are the tasks? In Windows, if we go to schedule tasks, this is a location where you can, or the user can add a scheduled task to run in the system at a specific time. So if I go to any one of them, so these tasks that you want them to run maybe regularly to back up your data, or you want to run them, for example, to delete specific files, or you want to run them in the night to upload your files to G Drive, like whatever was the thing that you want, you can use these tasks for. And the threat actor usually use it to create like a backdoor to go back into log into the system, or to run a specific application at a particular time. So as you can see, for I know this is by the way my system, not the victim system. So this is my task name. This is when it is executed. You can see run only when the user is logged into the system. And we have something important called the trigger. A trigger means when this will be executed. So this task, the one I chose here, the OneDrive update task, it will be executed one time at this time at 5 a.m. So usually you will see that it might be executed at a specific time. Sometimes it will be triggered based on application running. It will be triggered in like a specific action happen in the system. Now, so we know that the task name here was trigger this task and the action that this task do. So for example, this task will start a specific program. Sometimes it will delete a program. Sometimes it will make a connection. So whatever was, I'll see it here. And this is the condition that it will happen and some setting associated with it. So this is how tasks you can view them usually in a system. But for our case, in the So as you can see, we're currently at the software key. We can see the tasks under the key, which is called task cache. So if you expand this, we can have also, there is another folder or key called tasks. All the tasks in the system will be stored here. So for each task, you can see the key name, the path, when it was created, the last start and the last stop, and more information about these tasks. And under tree here, you can see we have different tasks in the system. As you can see, OneDrive update, those are like regular task, Microsoft updates. But for example, we can see this bitmap and we don't know what is this task. So we have this task, we have this information about it. What is this task? What does it do in the system? Currently, we don't see anything about it, but how we can investigate this more? What we can do is based on its ID. So the ID of this task is this, and it ends with this number 466A. What we can do, we can take this number and we can look within the task more about this bitmap task. So we have the ID, which is 466A. I'll go under tasks and I'll be looking for that ID. So either you take the ID and go search of it. We can do this 437. Or by the way, you can create a filter. Here you can just create a filter and look for it. So it's 437.5D. Yes, here it is. So either searching or you just create the filter, you will go and you find the task here. So this is the task, this is the author, the user created this task is user1, the path, the URI, the date, and we can see here the action and what triggered it. So you can see here, it's not readable, but we can see the actions. In the actions, you can see that this task will run an application called bitmapservice.exe. So here we can see the action. It will use the CMD to run this application. So this might be also another way to do resistance mechanism. And for more information about it, we will need to investigate more, either find what this application does, or if we have access to the attacker machine, we can find more information about it. So, excuse me, I just want to go here. So the persistence mechanism, as we said, there are different ways to prove if the threat attacker has access to the system or not. We have the scheduled tasks. They are stored in the task scheduler, and you can see them through registry keys. We have also the Windows services. These services are just a process managed by the operating system. They can help us to see if the user has created a service to be able to log into the system again or not. Okay, so before moving to the next artifact or next analysis, which is the event log analysis, what we can do, I want to go back to Cape and to show you how we can process the data easily with Cape. So here's Cape. Let me just hide everything. What we did before is just we used the target option to extract the artifact. And what we want to do that we want to process this artifact. However, I want to close everything because Cape is going to go and read the files. But if this file is used by different application, it will not be able to work. So just make sure that there is nothing used by Registry Explorer or whatever was the application you have to make sure that we don't have any error messages later. I close FTK. So far, I think we're good. Okay, perfect. Then what we are going to do now is that we are going to use a module option. We don't have to use the target option. We already have our data extracted. Now in the processing here, we have two options, the module source. What are the artifacts that you want to process? And again, when I say process, if you remember when we worked in prefetch, for example, so or SRAM, what we did here is that we used a SRAM ecmd.exe and we processed this file, which is the SRAM database.dat file, and we did the processing manually. The nice thing about Cape is that also it allows you to do this automatically. So what you can do is just you can determine the source. So my source is the data that we put here in the desktop. So if we go to desktop, Cape output, here we have all the information. It is mapped here in the I. So we are going to use the I directory. So HI, here is the output. Because my VHD file is stored here. And then I want to determine the output for the processing. Similar to what we did here. When we use the SRAM, we determine the CSV. This is the output for my data. So also here, we need to determine the output for the data. So what we can say, we can just create a folder. And I'll call it Cape processing output. And I'll use this as my destination. In my desktop, so here is my processing output. Okay, you can add this to add like the day and the month, but we don't need this now. What we can see here that if you want to process the data, what do you want to use to process the data? We have the AM cache parser. For example, if I scroll down, I want to show you that we have BECMD, for example. Do you want to use BECMD, for example? Do you want to use SRAM ECMD? Which are the tools that you want to use? However, I'm going to choose EasyParser. EasyParser, this option, will use all of the Eric Zimmerman parsers. So all of them will be here. As you can see, there are different ones. The AM cache parser, all the different parser that we need will be here. So instead of choosing them one by one, we can just choose all of them. Of course, if you have a case which has only, like, for example, you want to only analyze link file, you can use LECMD only. But currently, we want to analyze everything. Another thing I want to add is a tool called Hayabusa. And this one will also be helpful to analyze the log file, because next we are going to analyze the log file. So I want to use also Hayabusa. There are different tools. Eric Zimmerman also have a tool to analyze the event logs, which is this one, events XECMD. However, it's already included. We just wanted to show you another tool to analyze the artifacts. So I chose two modules, EasyParser and the Hayabusa. What is the export format that you want? Usually we use CSV. It's going to be easier for us to see everything. We have ignore FTK messages. You can, for example, debug messages to see more data if you want while it's analyzing. And by the way, I'm not sure if you noticed or that, every time I choose something, it will be added here. So because this is the GUI version of keb, this is the command that will be executed for the command line version of keb. So you can use, like, if you later want to use the command line, this is the command. So we have our options here. Everything is set. What we can do is that we can just go and run execute. Again, it's going to tell you choose to flush the data. It will wipe everything inside this folder. It's okay. We don't need anything from there. So you will start okay. That will start processing the data. We will wait until this finishes, and then we can move and talk about other artifacts. The PDF. So for analyzing the events, as we said, there are different ways to analyze them. There is Event Viewer, Hayabusa. We can use Timeline Explorer. If you are not going to use Event Viewer, you just use the Event Viewer in your system. So if you search for Event Viewer, and you can just add the event file, like open saved log and open the event file to analyze. However, we are going to wait for Hayabusa to show you how we can do this. By the way, this is to show you how you can use Hayabusa like manually if you want to process the data, how you do it. But because we already used this option in keb, you don't have to do this manually. Okay. So Professor Ali will continue now talking about the event logs.
Okay. So let's wait for our results to happen. I think, yeah, these are probably the Hayabusa results, I think. Yeah, as you can see. And by the way, one thing about Hayabusa, it's a Japanese tool, which is really a great tool for analyzing logs. And one thing that I can mention about this, or at least mention here, is if I go to Hayabusa, because this is when you download it, this is what you have. It does a lot of the like the analysis, the parsing, and the results for it based on Sigma rules. So if you go to Sigma rules, you can, let's say, we go to like, I'm not sure if you've seen a Sigma rule before or not, or if you've used it. But for example, let's say process creation, you can see there's a Sigma rule for every process, or like these depend on like community support and community support. So I just want to show you at least one probably that will make sense to you. Let's open this one. So let me open this one, and let me kind of why is this maximized? Oh, let's see. Can I?
From the font.
Yeah, the font is too big. So, and I'm not sure why it's no longer working as. So zoom out. Okay, so control. Okay, good. So as you can see here, we have the title of this Sigma rule. And by the way, think of Sigma rule as a language or a template or a format that could be used to investigate or kind of like, yes, let's say investigate or detect an activity, but it's kind of unrelated to a SIEM. So it's not related to a specific SIEM. So I'd say it's not a rule written for Splunk. It's not a rule written for, let's say, Elastic. It's not a rule written for QRadar, etc. It's a generic rule that you can go and apply it on any one of those systems. So it's a way of kind of formatting and saying, if we see this type of activity, then it means this. So it's kind of a really good way to use. And Hayabusa depends on them. So as you can see here, it's telling you the detection mechanism here is process creation. The event ID is 1, and the channel where the event is coming from, which is from Sysmon. And then the selection contains like calc.exe with these, and then the other one, image, ends with calc.exe. Now it will tell you image contains system32, etc. This is just one example, by the way. Maybe I go and open another one. Let me see one that maybe like CMD. Let's see this one. Same thing, the title, file and subfolder enumeration via dir command. An ID is a GeoID for this. Status, it's in testing, so they kind of flag them, give it a status. There's a description, which will help you understand what is this Sigma rule for. So detect usage of the dir command, part of Windows CMD, etc. And you can see where is this being pulled from. And like if it's referenced in like the MITRE ATT&CK framework, it's also tagged in there. It's telling you that it's coming from Sysmon, or it's being tagged under Sysmon, and that's where we actually even saw it. So you can see the log source, process creation, when the product is Windows, and then again, these are the details about this rule. So Sigma is used in this case, okay, with Hayabusa. So that's why Hayabusa usually will give you a lot of good output once it finishes the processing. So as you can see, the processing has ended. Now what we could do is we can go ahead and use Timeline Explorer again in order to look at the events. Now, one thing I do want to mention here, by the way, is these require some certain setup. So for example, if you are looking for Hayabusa, so if you get this one, if you just double click on it, by the way, it will tell you what do you need to do in order to use it with Cape. Okay, so all you need to do, as you can see here, create a folder, which is this, and then within the directory modules bin, and so on and so forth. So everything you need, by the way, about using any of these tools with Cape is actually documented for you. So anything you need, again, all you need to do is probably like double click on it. You can see the documentation on how to integrate that with Cape. And this will make, by the way, your investigation much faster, because you can now automate things and scale it on multiple systems as well. So we're done with that. Let's go ahead and look at our results, which I think Mariam stored on the desktop. So if we go here, and now we go to event logs, we can see we have the event logs from Eric's tools, which is the EVT X ECMD. And we also have logs from the Hayabusa output, okay? So let's get those, load them, and start looking into them. Okay, so that's one. Then let's load the other one. Now, each one of them, by the way, formats and filters them differently. So they won't be exactly the same, but they are both going to be useful to you with your investigation. If we go here, because by the way, let me just clear this. This is how the rules will look like. I'm going to clear all the filters so I can show you how we can filter them and do all of that. So one thing is I usually like to look at things in a way. So you can either, by the way, combine them or group them by the application or the channel, sorry, or you can combine them by the like the provider. Okay, it's really up to you what you want. As you can see, there's a lot of entries in here. You can still also later combine them with channel or with whatever you want, by the way. So if you later want to combine them or group them with something else, that's completely up to you. If you want to combine them by the provider or the channel, that's also up to you. So if I do this again, you can see this is now showing you how we can look at when we say security. That's all the evidence in the security. If we say setup, it's in setup, Windows in Windows, and so on and so forth. Okay, so that's part one. Now, in our case, we want to look at user activity that has been added to the system. So because we saw, let's say a user has been added to the system, okay, which Professor Mariam was showing you when she was looking at the SAM file or the SAM Hive, which is the security account manager. Okay, so if we want to do that, those will be stored within the security entry over here. Okay, and if we now, like, let's say, group them by the map description, so we can do a map description over here. We can see a member was added to the group, a member was added to the local group, and we can see a new account was created. Now, if I expand that, I can see that these were the new accounts that were created on, and this is the computer. So if I scroll all the way to the right-hand side, I can see the name of the users which were added to the system. Now, we can see here we have WDAG utility account. We have default user 0, user 1, and then default. Now, we can see all of that. But two of them, one of them is a default account, and one of them is an account which is used when the system is installed. So what we need to do also is probably the time of creation. We need to also filter down the time of creation, because as you can see here, 3 of those events happened in 2022, and our investigation or our case happened in November. Excuse me. So what we can do is we can come here, and by the way, once you hover over this entry, we can see here this funnel here in the top right corner. So if you click on it, what we can do is go to date filters or values. So in our case, we can see we have 2020 and December, we have 2023 and November. So let's say we are interested in looking at all of the events which happened in November 13. So if we just do that now, this is now going to minimize, by the way, as you can see down here, total lines are 60,000 something, but now we only have 15,000 events listed in here. So we kind of minimize the amount of events we are looking into. You are definitely going to go and do more filtering and look and do more like a deeper dive into the events, because probably this is still a lot, by the way. So you need to know what you're going to be filtering, what are you looking for, and dive deeper in that direction. So if we go back and go to security, now we can see that this is the user account. So you can see this, we have only one single entry. Okay, we have one single entry in here. Okay, which is, this is the user that has been created on the system. So now we know that this user has been created on the system within November 13th, 2023. Okay, that's when we had this case, by the way, created. As you can see, by the way, down here, we can see this is the filter. So if you go to edit the filter, by the way, if you click on edit filter, you can build these filters also yourself. You can go ahead and build these filters yourself. So if you want to filter down something else, you can then say, for example, and do, let's say, you want to put like an event ID equals, and then do something in there. So it's really up to you. If you want to write those events, you can do that. So you do that filter, I mean. and if you want to do that manually. Now, what we can see also in here, after this user was, let's say, created, if we look at the user account was changed, and if we look at, let's look at something else, we can see the login, log off, by the way, on this, like this user as well. We can also see this, which is what we want to look at. So we can see here, if we go there, we can see that there was a user account added to a local group. So let's see, what do we have in there? Let's see here. If we can, and really it's up to you how you want to look at this. So we can see these are some results being pulled. I want to show and the result, by the way, was success. But I want to see over here probably. Yes, so we can see, by the way, that this is an SID, which is a security identifier of the user. And this is, by the way, the security identifier of the user that was added, which is default. As you can see, it ends with 1002, which is the RID of the user, which is the relative ID. So we can see all of these events. Okay, we can see this user was added like to the users, administrator, and remote desktop user. Which user was added to those groups? It was the user that has the SID, this, which is ending with 1002. So we know that this user now has remote desktop access capabilities. Okay, we know this user has remote desktop access capabilities. Okay, now if we go to, so this is one. And if also you want to look at, like, let's say, log in, log off, okay, we can also see that. So we can see the here over here, the account logged off. When did the account log off? And which user logged off? So you can see user one, and then this user was logged in one time, and the logon type is 3. So we expect probably this to be from a remote network. If we also look at the failed logons, there was 1. We can see successful logon. So if we expand that, by the way, we can see as well, these were all successful logons. Okay, we can see that over here. And if I scroll down, probably like to the end, down, because we had a lot of events in here. Okay, so let me scroll down. So if we look at this one, for example, which is our default user, we can see this is where the remote host, and this also proves our suspicion that this is where this user was logging in from. Okay, we saw the logon type 3, okay, and this is where that user was logging in to that system. Now, another thing we can do is, if we want to look at the like the RDP, so if we want to test or check if there was really RDP being used in here, so we will need to go to a certain channel. Let's filter that channel in here. So in here, what I'm going to do, I'm going to do a filter based on the terminal services. So I can do a search here quickly, terminal. And this is to help you, by the way, narrow down your search. So it's really up to you. So terminal services, and then we want to look at the remote connection manager. Okay, and we want to look at the operational data in there. Now, if we look now, by the way, we had 60,623. We are now looking at only 11 events. So we can see here, these are the 11 events, by the way. We can see here, it's telling me that the RDP listener received a connection. Okay, we can see that over here. And if we expand this, we can see event ID number 1149, which means that there is an event authentication was successful. So, and we can see which was the user, which it was the user default, which happened to log in remotely onto this system. Okay, so this is really going to be useful to you. But again, the way you can dig deeper is you need to know what are you looking for, kind of. If we go to the Hayabusa, by the way, it's similar to what Eric's tool is giving you, but kind of like categorizing them probably like differently. So if we look at, let's say, if here, as you can see, we have computer, probably in this case, because we are only looking at one system, we can kind of exclude that. So we can say hide this column because I don't want it. Because again, this is probably, we only have one system, so we can easily, or we can kind of let go of that. But if we had, let's say, multiple systems, we can then group them by system if we want. But again, we don't have that in our case. I'm going to group them again by channel. We can see now we have much less because these are not based on maps. These Eric's tools are based on maps, which is built in with the tool, or kind of like also get updated based on new kind of contributions from the community. But these are based on the rules that I just showed you. So if we now look at, let's say, the channels over here, I'm not sure if I have any filters in there. I hope there is no filter. So I think we don't have any filter. Now, anyway, in this case, you can see we only have a few entries in there, by the way. We don't have a lot of entries. Let me just make sure I don't have any filters. Or probably, by the way, yeah, it seems, by the way, this did not pull all of the let's say the results. Now what you could do, probably this is useful, like we can see the logs have been deleted, so that might be useful. We can see ps exec has been used on the system, so it might also be useful. Now in this case, probably it was a configuration that we needed to do using Hayabusa, but in any case, let's say we were not able to do that using Cape. What you can do, it can easily be done as well. So let me go to, just to show you how we can do this. So if I go to, yeah, I want to go to my tools, back to tools, Hayabusa. Okay, so again, if you just run, by the way, oh yes, this is CMD. Yes, thank you. So if we just do this, by the way, and run the tool by itself, it should give you what you need to do. Okay, it should give you some data or details. Now, in my case, I want to create a timeline, so I'm going to use that. I also want to use -d to tell it, I want you to go and process all of the logs within a certain directory. So I'm going to go and tell it which directory I'm interested in, which is under Windows System 32. Can you see, by the way, my screen? Because
yes.
Okay. And then if we go to this location, logs. So what I can do is I can do this, and then I can do my output and save it in C users, IE user desktop. And this, I think, by the way, is also on the, I think it was on the screen. Yep, as you can see. So even if later on you want to do that, you can do that yourself. So results, I'm going to do Hayabusa just to kind of differentiate and know that this is what this is about. Now, as you can see, the newer version, by the way, is going to be asking you some questions. So let's see. I think it's still processing or reading them. Also, if you see, there is one of the options to update rules, because by the way, these rules do get updated regularly by the community. So it's also good to do an update. But why is this stuck now? Let's just give it a couple of minutes, a moment or two. Because it should, by the way, give me more results than what we saw currently in the output. So let's just wait a little bit for this. Okay. So it's telling you it's loading the texture rules. And as you can see, it was probably, I did not select. Let me see again. Okay. I need to delete the file. Okay, let me just do this quickly. Yeah, so this is what I was talking about. So it's telling you here which rules do you want to apply, all alert rules or all alert event and alert rules. So it's really up to you. I'm going to go with this option over here. It's telling you include deprecated rules, which are 214. The default is no. I'm going to leave the default. Include unsupported rules, also no. Include noisy rules. We can also say no. It's up to you. Include sysmon rules. Those are important. So yes. And now it's going to do the processing for you. So even if higher, let's say CAPE wasn't able of doing that for maybe our configuration, we need to do some configurations, we can go ahead and do that. Now, as you can see, by the way, in the summary, I have a lot of more results than I had previously. So let's go ahead now and load the new rule that we parsed. So results, and we have Hayabusa 2. And now, as you can see, we have much more. Again, I'm going to remove the hide this column. I don't want it. I'm going to group by this column, which is the channel. And now I have much more data in there. We can see these are for RDP logon. We can see the default, and it's telling you where did it log on from. So kind of these rules also help you to look at those details. So you can see there's a lot of RDP log on, log off, RDP disconnect, which users did that. We can also go back. Okay, we can also go back and filter based on our timestamp. So if I hover over this values, and again, I'm interested in November 13, now I have far much less rules. I only have 161 rules in there, or let's say, sorry, results in there, instead of looking at 472. Now, you might say, this is showing me much less rules than EVTX. That's true, because EVTX, by the way, will go and parse all of those Windows event logs. In this case, this is only parsing events which are based on some rules found that come with the with Hayabusa. But anyway, you can see if there's like a process has been created, we can see a login, a log off. We can see all of that now with this being used like in here. You can also then, maybe it's really up to you, group them by the rule title. So if you want to group them by that, and then makes it even more easier for you to look at these events. So for example, let's see over here, this is something that Eric's tool will not tell you, because I'm not sure, maybe there isn't a new like rule for that or a map for it. But over here we can see a rule telling us that Meterpreter or Cobalt Strike service has been installed, and if we expand it, we can see the details of that service and where it was located. We can see suspicious service path. So if we expand that, we can see where is this, excuse me. We can see this detail. If we expand also, we can see there's a service being installed. If we expand it, we can see the details about this service, by the way, and then we can go and like investigate it more. So as you can see in this case, the service is called Microsoft Network Simulator Service. Is there a real service called like that? Professor Mariam showed the services which were installed, or like, and these were installed within a time frame, so probably they are suspicious, we need to go and like investigate them. As you can see here, with these rules, it made it much more easier for us to kind of go ahead and look into them. But with just looking at logs, probably didn't tell us that this is suspicious or not. With these rules, I would say we did get a much more advantage, or made it much more easier for us that way. We can also see here what executables has been used on the system, as you can see over here. And especially, by the way, if this system had like sysmon installed on the system, so if there's any kind of like system feature which is logging all of the processes which are going to be created, etc., this will give you more granularity into what to look for and more evidence and more data to investigate. Let's see, what do we have next? So we talked about this. We've talked about the event logs, logs in, log out, etc. RDP activity, we also covered that. Probably we'll talk about the team viewer.
Maybe we see the questions. We have a lot of questions.
Yeah, we can do. Do you want to do the team viewer quickly, or we can quickly, by the way, give you an idea about team viewer? Let me quickly give you just an idea about that, and I'll leave it for you later to do more investigation. Again, you do have the data set, it's with you. Please spend more time. This case can kind of help you learn a lot about computer forensics, especially on a Windows system, and then computer forensics on like a Linux system, because also you have the CAPE system in over there as well. Now, if we go to program files and then go to team viewer, now usually one of the questions was, has team viewer being used? So the question was, has team viewer being used? Now, when team viewer gets used, by the way, there will be a file which is about team viewer connections. So if we look at that log file, so maybe let's categorize them by the type. And if we look at these log files, by the way, it will be a log file saying, if I remember correctly, team viewer 15 underscore incoming connection. Now we don't see an incoming connection in there. So there are two things that might have happened. One, that file has been deleted. That's a possibility. So we need to check at the file system level, has that file been deleted? And two, then probably this system has really not been, team viewer was not really being used. If we open this log, by the way, and like go through it, okay, you will see that probably after reading it, I'll leave that for you. But if you look into this and like read about it, so you can see the timestamps, when was this used, you will see that team viewer was actually not used to kind of access the system. Okay, and again, two proofs we have. I'm going to give you kind of a hint. Proof number one, the team viewer 15 underscore incoming connection.log does not exist. Proof number two is if you go check the file system event logs of the file system, or not the event logs, but the journal logs of the file system, you'll also see two things. One, that incoming connection entry was not created. That's one. And two, it was also not deleted. So those are proof that team viewer has not been used on the system for access, or it has, or I would say team viewer did start on the system, because we can clearly see that. And if we look at the prefetch files, etc., we can see that team viewer was used. But if we go ahead and like check whether it has been used to connect to the system, we won't find any details in there. So we'll stop here. Let's go back and look at your questions and see if there are any questions that we will start to answer. I'm going to go, by the way, from the beginning and answer all of your questions. Question number one, are we Turkish? No. Question number two, we are also not from Russia, so we are not Russians. But I don't think, by the way, any of that matters. We respect people wherever they come from, where they're originally from. can you please speak in Urdu? Unfortunately, we don't speak Urdu, so I'm sorry about that. I wish I can, at this age, learn a new language. I would have learned Urdu, because we do have, by the way, a good friend of ours, which is actually from your area. Okay, what is the next question? In what scenarios would the lack of metadata and compression in DD be advantages over E01?
So I think this question was when we talked about the difference between DD and E01. So we said that E01 is preferred because it stores the metadata and it can compress the data. So like usually it is preferred over DD because again, DD cannot be compressed. However, like maybe the only thing that come in my mind, for example, if you have a Linux machine and you don't want to install tools, or you want to take an image of like a drive, you just make it DD, and this is the only option that you have because DD is already installed there. Other than that, usually we prefer E01 over DD images. Do you have any other?
Yeah, I agree with you. Probably the only case is when we don't have a tool to acquire in E01 format, probably. Then DD will be good. Other than that, E01 is, by the way, the standard and E01 stands for evidence witness format. It's a very standard format which is used, and I would say 99% of the tools understand and know how to parse it, work with it, and load it, etc. Definitely DD is a raw format, so it's much easier, but again, that's more of the standard. Now, what is the price of a full DFIR course?
Price, I think.
The price?
I think the question was what about the price of a full DFIR course? So
yeah, go ahead.
Like we're not here to promote for the courses, but however, if you want to know, like the courses are hopefully are affordable. A full DFIR course in Cyber 5W is $600, and currently I think there is a discount for on-demand courses. There is 30% discount, and there is so. Yeah,
again, by the way, we are not here to market our training. We just did this because Hamid reached out to us and asked us if we can do this workshop. So we are really doing it for free and for like just sharing our knowledge with you and learning from you as well. So nothing related to, but if you do want to kind of look into like the cost of our training, please go check them on our website. Other than that, we are not here to do any kind of marketing. So if we continue, what is the next question? Is there any other tools that we are going to use for data recovery? So by the way, it's a nice question. Data recovery, there is a tool which is called, which is really nice, called Test Disk. By the way, it's a free tool, so you can use that to do two things. One, if you have like a drive which is corrupted, you can fix it with it. And it comes with a tool called Photorec. And Photorec is a tool that you can use to do data recovery. So then you can do that and recover files from a drive. Also, you can use Autopsy or any other forensic tool. By the way, most of them have like data recovery capabilities.
Yeah, I just want to mention also that we didn't do any data recovery today, but I know that you're publishing a course very soon about data recovery.
Yeah, there will be a course, by the way, published probably next week. It starts about the basics of data recovery, and you can watch, by the way, and do the course for free if you want. If you want a VM, then you'll probably need to pay for that, but you can still watch, do all of the work for completely for free. You don't need to pay anything for any of that. Again, we are both of us are educators, and we do want to share a lot of our knowledge because, as you all know, Zakat al-Ilm Nashra. What is the next question?
Is there going to be an overview of the DFIR tools in the VHDX? So I don't think we have time, but maybe that will be some webinar we could do.
Yeah, probably we can do like a video or a webinar on just going over the tools, what they are, and where you can use them. Probably that's a good like a session to do also as well. What if prefetch files are corrupted? That could happen, by the way. The prefetch files could be corrupted. You'll have two things to do. One or two things probably to keep in mind. One is don't always focus on one single artifact, because there's a lot of other artifacts that you can use to support your investigation. So even if one is missing, probably you can look at some other evidence that you can use for your investigation. Two, you can also try to fix the prefetch file. So at the end, these files use like a certain file format. So once you understand the binary file format of the file, then probably you can go and try and fix it, and then use it and parse that. We do have, I would say, a complex case, which we will be sharing publicly in the near future, that kind of uses something similar to what you were asking here about corrupted prefetch file. So hopefully that will be another good case. I would highly recommend you check as well.
I would mention also that one of the assignments we have, or the tasks we have, is to carve for a prefetch file. So even if the file is deleted, can we find the system and carve it?
Can you repeat? Sorry, again.
If the prefetch file is deleted, we can carve for the
Oh,
prefetch
yeah,
file
yeah.
because it has a signature.
Mhm.
So this is another case where you can, for example, retrieve the file. Another similar question: how can we recover the corrupted files?
Yeah, again, one of the ways you can recover corrupted files is using a tool like TestDisk. Most of the tools which come with forensic suites can recover files, but again, if it's corrupted, mostly if you have a tool to fix it, you can use it. Otherwise, a lot of, by the way, times, especially in advanced cases, you'll need to fix them yourself. So don't expect all the time that it's just about running a tool, getting the results, looking at the answers. Sometimes you'll need to really dig deeper and do some work yourself. In case of ransomware attacked PC, is forensics even possible in this scenario? Yeah, at least, by the way, so let's say in a ransomware investigation, now maybe the files were encrypted, but you still want to know what happened on the system, where did the threat actor come from, what was like the weakness on the system that led to the threat actor getting access to the system. So even if the files were corrupted or now encrypted, whatever, you still want to know what happened on the system, because most of the times, by the way, threat actors, especially with ransomware cases, they are using a third party, so they buy the access itself. So there's like an initial access broker, they buy the access. So how did that initial access broker actually got to your system? That's also important to investigate. So if the goal is to investigate or retrieve the data might be gone, and that's now a different scenario or a different investigation. But if the goal is to at least find out what happened, where did they come from, what was done on the system, then yes, still we should investigate. We should investigate the system. Can you suggest some Linux system log analysis tool like we have Chainsaw Hayabusa? I think, by the way, both of them do work on Linux. I could be wrong, but there is a UAC tool called UAC. We'll probably also do a webinar on Linux. By the way, there's a lot of webinars and workshops we've done on Linux, and they are all publicly available on you can find them over here. And there's a lot of, by the way, also free material. So if you go to linuxdfir.ashamari.com, you will find a lot of our talks, workshops over here. A lot of them have recordings and videos and material that you can use also if you want to do that. What else? Can we reach out freely if there are any issues with our forensics journey? Please feel free to reach out to us. We'll do our best to respond to you. At the end, we also have our daily lives and work, but we'll do our best to get back to you. Please feel free to reach out if you have any questions. And we do share at the end, by the way, here, there is our again, if you want to reach out on social media, This is my Twitter, or now it's called X account, and Professor Mariam's account, or if you want to send an email to info@cyber5. We do, by the way, have a Discord channel, but it's not really very well active. So yeah, reach out by email or by social media. How can we get Cellebrite software free of cost? I don't think you can. It's a commercial software, so you can't do that. شكرا قائمين على الورشة مجهود تشكرون عليه أسعدكم الله الدنيا. جزاكم الله خير. Thank you too for your prayers. Can you please tell about some important sites for cybersecurity courses? So when you say cybersecurity, by the way, it's a really general umbrella, I would say, which has underneath it a lot of different fields. So we have a lot of, let's say, offensive side, defensive side. We have the investigations. So I can't just kind of tell you like one place, because there are a lot of really good locations. But probably, by the way, there's a lot of on YouTube video, like courses, videos, etc. There's also Hack the Box. We highly recommend Hack the Box for even blue team work. I think they now are adding a lot of blue team stuff, not just for red team and CTF. So probably those are good resources. And definitely Cyber5, we have a lot of free content. So if you want to check that there, which is the best tip for us to conclude some answers? What are we going to find in the investigations at the start?
So what I think, so the question is, what are we gonna find in the investigation at the start? So there is no one way to do the investigation, but what we recommend usually is that you always have like a checklist. For example, I want to search for the initial access, so I should go to search for any executable. I should go search for any files that has been executed, etc. For example, I want to check for persistence mechanism. I'll have a checklist. Go check for any suspicious user have been created, any scheduled task, any services. Is there anything in the run? So there is no one way to do the investigation, and like there is no like one answer for this. But usually the checklist, I think this is my recommendation. Not sure what you think.
Mm-hmm.
To find like to have a checklist in how to do the investigation, and this will be like will be step by step, so you have to create it based on your investigation. So I create it now, next case I will update it, etc. The other question is, there are any free software to create image of Android now? So there is like, I didn't hear of, but what I would suggest is that you can use ADB. ADB is free, and you can install it and you can use it to create image of Android. It might not be like a full image, but you can use ADB to copy the files and the folders that of your interest. And you can also, so I think ADB is the one that you can use.
If an organization is actively under attack, is it more effective to immediately block the attacker or let them continue to gather more intelligence? That's really something, it's a nice question, by the way. It's something to evaluate, like the risk of leaving them actively operating within your network, or to kind of like block them and now respond to what happened. It's really a risk that multiple teams will be involved in evaluating and assessing before you take that decision. So because it's also important, by the way, to know, do I really know what are the like the accesses that they have? Is it just one access? If I like block it, now they no longer have any other access? Or do I have enough information to go and say, yes, it's only coming from this location, I'm going to block and now start my investigation or remediation, etc. So it's not kind of like a one single answer to that. Excuse me, that was my reminder. Some person says that autopsy is complicated to use. I would say, by the way, don't live in someone else's shoes or in someone else's based on someone else's experience. Autopsy is free. Download it, use it yourself, and then check it out. Why would I depend on someone telling me that, oh, autopsy is complicated. You download it, use it yourself, and see for yourself whether it's complicated or not. I think that's probably better than someone throwing you away from using a tool, even though and by the way, even if they are an expert, I might be good at something and I say, oh, my opinion is that autopsy is not good, just like as an example, but that could be just me. So don't build your experience based on someone else. Maybe, especially now, I would say check it out, use it yourself, and then based on that you can say in the future whether you want to use it or not. Do you want to add something about that?
Maybe regarding basic questions, sometimes in autopsy, some things are not direct, like you will get it directly. So other tools will show you directly, like this is what you need, this is the image, this is the file, etc. In autopsy, sometimes you need to know the path for a file to get the information, or you need to do more analysis. But I think this will give you more like better investigation skills. So if you do that, it will be better for you than maybe other tools. This is my opinion again. Okay. I think we already answered this, the lack of metadata and compression better over
Okay,
E01.
yes.
If you suspect that an image contains hidden data via steganography, what tools and techniques would you use to detect and extract the concealed information without compromising its integrity?
So, like, I don't have on the top of my head a tool to tell you about that.
I think autopsy also, for example, if there is a file hidden inside another file, so if you have a zip file hidden inside an image,
Yeah, it has a
autopsy
feature can do that.
extract it.
Most tools actually can do
Yeah.
that. Most forensic suites can do that.
But that was in the steganography technique also. So,
But if you work on a copy, by the way, that's not going to affect the integrity, because you're going to work on a copy of the image, which is what we always recommend you to do.
yes.
Thank you for the informative session. Thank you too for attending and listening to us speak for 3 hours. Not yet, but so yeah, thank you too. Just a simple question. I often face the log replay issue when loading the collected registry hives, and can you explain how to avoid it? I wouldn't avoid it, by the way. That's so the log replay. What happens is when you collect those logs, by the way, there is some logs that have, or some data that has been written to the log file, and it has not been written back to the log itself, to the Windows registry itself. So it's important, by the way, to use those logs, because then that way you can replay them back into the registry file, and then that way you have a full view of what is in there, instead of like ignoring them. It's really up to you. You can just say no and don't replay them, but I would say they do have some information that you could probably use. If a file header does not match its extension, what does this indicate, and how would we determine whether it's a malicious legitimate activity? So a file header, by the way, most forensic toolkits nowadays, like Autopsy, etc., they can do like a file mismatch check. They will tell you if the file, like you said, the extension doesn't match the header. I would say that's suspicious, by the way. Why would a file have a different extension? Usually that's a kind of act of exfiltration or hiding something. So I would look at that as suspicious. And when we say suspicious, by the way, that does not mean it's malicious. So suspicious means I need to check it out. Why that is happening, and so on and so forth. Do you got any LinkedIn accounts? Yeah, we do have a LinkedIn account. We can, if you search our names, Ali Hadi or Mariam Kader, you will find them. The links and references at the end of the group. Yeah, we can share those with Hamid as well, with the recording. So later on you can access them and connect with us if you want. One thing to keep, by the way, I do want to say I'm not a LinkedIn guy, so I probably visit LinkedIn every 2-3 months, by the way. So if you message me over there, probably I won't respond until 2-3 months. I don't know, it depends. But if you message me over Twitter or by email, I usually will respond much faster. So what about TryHackMe and Portswigger? Again, by the way, all of these websites and training platforms are really good. TryHackMe is also a good platform. Nothing, I know I mentioned Hack the Box, but there's really a lot of other websites like Zero Point Security for offensive red teaming. There's a lot of really good courses and websites out there. Don't get me wrong when I mentioned Hack the Box. That doesn't take anything away from everyone else. What is your
Yeah, it is this one.
any good software to crack the zip file? Because as an evidence, I got a zip file and I had to analyze it in anti-forensics. I don't have one in the top of my head, to be honest with you. So I'm sorry I can't answer that question now. Do you have anything on the top of your head?
Maybe like reverse engineer the file or not.
No. What is your opinion of that AI effect on digital forensics? I think AI can speed things up, by the way. I do hope to see AI helping in speeding things up. But I don't think, by the way, it's going to take anything away from you becoming an investigator. At the end, by the way, all of the data that you saw today, we went through, that is all depending on human intelligence. And that human intelligence cannot be put, at least until now, easily into a tool or an AI system and telling it to go and do all of this completely for you. Until now, probably it might change in the future, but I would say you are still valuable as a person, as a human. Your brain is still one of the best. At the end, these AI systems were built using your brain. So still, I would say, I hope we can use AI to speed things up and maybe automate some things, but it's not going to replace you. So don't worry, you'll still find a job. What else is there?
Like during investigation or encounter encrypted files.
Decryption key, what methods would you use to bypass? That really depends on the encryption method. If there is an encryption method that is like it's using a highly secure, mathematically proved encryption method, then with all respect, then you're not going to be able to decrypt that. But if you're using, let's say, just an example, if there's a ransomware or if there's an attack where an encryptor was used to encrypt files, and let's say, because there were cases like that, and then the key was stored in like the registry or it was hidden somewhere on the system, then probably finding that tool, reversing it and finding how it was operating, then you could probably find the key and then use it. What else? We are trying to, by the way, answer all of your questions. I think
So there was a question about, because like whenever I get a new one, all the questions go away. It was about like if I have like different tools and they have conflict result. So I use tool 1, there is a result, tool 2, there is a different result. What should I do?
then you probably need to
analysis.
manual analysis. Yes, it's a great question, by the way, and that's where, by the way, it will show the difference between someone who depends on a tool and someone who knows what they are doing. Because if you just depend on a tool, kind of like we say, you become the tool. But if you depend on your knowledge and then you kind of are verifying or validating your work with another result, then you know there is something wrong and you need to dig deeper. It's not always, by the way, straightforward. It's not about just you running tools. What forensic techniques can we use to recover partially overwritten or corrupted data, and how do we ensure its admissibility in court? Now, by the way, courts are different from one location to another. Corrupted data, it really depends if it's partially deleted or partially corrupted. There was a research I saw, but it was for a highly classified organization. They were able to kind of rebuild the structure of the file. So as long as you know how the structure of the file is created, you probably will be able to rebuild it. But again, those are not that easy to be done. Is there anything else? What if the attacker removes all the evidence from the system? Probably, in my opinion, by the way, go try do that yourself and see, can you really cover all of your tracks? Probably doing one thing will lead to an artifact somewhere else. And really, our systems, by the way, are tracking a lot of our activity. We didn't show everything because there's a lot of in Windows investigations, and a lot of what you do on your system, like even when you open just a document or even when you just open a file, all of that is being tracked by your system. So it's not as easy as you think it is to kind of just go and delete all of your evidence. What else do we have?
So this was like conversation about
Okay,
the
okay.
question. I just want to make sure if there is anything in here.
If evidence points to data being sold on the dark web, how would you safely gather intelligence without exposing yourself or your... So the evidence you mean on your system? I didn't understand, by the way, the question. If it's on my end, then I can look at my end of data. But if it's somewhere else, then that's a different thing. What forensic step would you take to investigate side channel attacks, such as those exploiting power consumption or electromagnetic emission? I probably haven't done anything like that, by the way, and I think those will require some physical tools probably to detect those type of power consumption or electromagnetic fields. That's not my area. I don't know the answer to that question. Okay, then. So that's it for our session today. Thank you all for joining us today, and we hope you learned something, or we hope you took away something from our session. So thank you all. Thanks to Hamid for organizing this with us. We appreciate the opportunity to speak to you today, and we will be sharing all of the material later on. Yeah, thank you all.
Thank you so much, everyone.
Thank you so much for your hard work and your actually amazing session. I really appreciate it.